maybe I'm going to really go crazy here and record myself doing this. So if I screw it up, oh well, but at least we'll have it for later. So here's my quick sketch of the planet. Here's our equator. Where is the warm water? Where's the water getting warm? Yeah, right. So this area, the central part around the tropics, is getting the most sun. So you have warm water here. And generally speaking, the salt content is about the same around here. Now, as you get close to the shore, close to ocean or land where there are big river mouths dumping fresh water in, that's where you get differences in density. But generally speaking, in the open ocean, the salt content is roughly the same. It's a pretty big place. It's hard to dilute that salt. So you have this warm water here, and you have colder water up at at both poles. Now, what happens is, as the water at the North Pole, so let's go, let's zoom in here at the North Pole. Let's imagine some water right up here. And I'd love it if you were watching here, just so hopefully you can follow along. So we have this cold, cold water up here on the North Pole. As it gets colder, what happens to its density? Other way around. As it gets colder, its density goes up. It sort of gets more compact. As its density goes up, think about our lake example here in New Hampshire. Where does that cold water go? In terms of depth, where does it move?
Turns into ice.
It either turns into ice or it sinks. So you have cold water, oh dear, near the surface that sinks downward. It gets deeper. So the cold water goes deeper into the ocean. It sinks down. And what's weird is if you have a big pool of water and you take water over here on the left side and you move it down, what's going to happen to the water over here on the surface? It's going to move over to refill it. You see what I mean? Like if I could do a side view, that's a really hard thing to think about. Here's a dish. I'm now looking at the side view of water, and I remove water from this area right here, or I make the water in this area go downward. Like I could sort of grab some water and sort of move it downward in some way. I don't know how I would do it. Just imagine that I could. If I could do that and move that water downward, the same amount of water over here would move over to take its place. What do you think about that? Manik, does that make sense to you? Casey, do you follow that logic? Okay. So if I move water down and this water moves over, I've sort of begun to create a current. That's kind of what a pump does, right? That's how pumps pump water. They grab a little bit of water and they move it, and that creates, we call it suction. But really what's happening is when you move this chunk of water over, water moves over to take its place. And you keep moving it, and you keep creating suction, and you create flow. And you get this current moving around. That happens on a global scale. Okay, so the water at the surface near the poles gets cold. It sinks down. That means the water near the surface of or on the surface but closer to the poles gets pulled toward the poles. And then it gets cold, and then it sinks. Meanwhile, this water that's at the bottom sort of has nowhere else to go but down back toward the tropics, where eventually it gets pulled back up and it gets warmed. And you have these currents, these great ocean currents that circulate from the equator to the poles. It's happening in both hemispheres. Water circulates on the surface from the equator toward the pole, goes deep, and gets carried back the other way. Remember on is it Finding Dory or Finding Nemo when they're riding the big jet stream with the turtles, or the ocean currents with the turtles? Right? Come on. Which one is it? that Finding Nemo, right? And they get off there's like some off ramp. I mean, some of that is a little bit not real, but the idea there is that this is a big ocean current. It's circulating water. Okay, so that's the big premise of this circulating water. So now go back and let's look at it. Here's the salt water near Greenland that is being pulled, that generally moves toward the north, gets cold, and generally circulates downward as it gets heavier and heavier and moves back south. Okay, so this is going north, north. Put an R in there, Derek. North. So the water moves north, gets cooled, gets more dense, moves underwater, gets carried back south. Now, suddenly, we have a bunch of fresh water being dumped into this conveyor. What's that fresh water going to do locally right there? How's it going to change the density? It's going to lower the density. It's going to make it less, basically it's going to change it such that less of this water feels pulled downward. Because suddenly there's less saltiness here near the Greenland coast because there's more fresh water being dumped in. And so what you have on a global scale, and this is really happening at each pole, is a weakening of these currents as the caps made of ice melt and dump more fresh water in. It changes the strength of the deep sea currents.